I want to welcome you to ATech's training on the 4810 Applied Electrical Trainer. If you aren't familiar with ATech, I wanted to make sure you understand they were founded in 1984, and what they develop is products that teach hands-on to the students for automotive diagnostics. They have products that are available for the OEMs like Ford, Chrysler, General Motors. They have done that, and they also have done for secondary education, which is your high schools, community college, military, and a lot of the technical schools have their equipment in their bag. And they're an ASE accredited training provider. 4810 Applied Electrical Trainer presents the study of electricity and electrical circuits, is what they tell you on a lot of the information. It also has a flexibility so you can have instructors create their own circuits or test for measurement and evaluations. You're not stuck with just the curriculum that is developed for you. You can develop your own curriculum and your own circuits. And we have two additional ports in the bottom which allows you to add on devices that you can do and test. The student's going to learn the areas up here. The biggest one you're going to learn with any student, you're going to have to teach them how to use voltage, current, and resistance. Those are the three main tests that you're going to use. That's part of Ohm's law. We also have to look at the power in the circuit. Now on this particular tool, you actually have a 5-volt power supply and you have a 12-volt power supply. So I will be able to show you that on the tool in just a few minutes. You're going to learn the most critical test that you're going to learn on this one. It's what's called voltage drops. If a person understands voltage drops, they have ability to diagnose the circuit properly. Because if you keep in mind, voltage always drops as it goes across the circuit as it's being used. So it's something you have to learn and transmit to your students so they learn it so they can apply it when they get out in the field. You're going to be able to go over series circuits, parallel circuits, do some diagnostic testing. And the other thing is we start off in the beginning teaching you how to use your meter. We're going to show you how to do a resistance check. We're going in the student guide over here, it's going to tell you how to do resistance check, the current, and other tests on it. The other thing is where a lot of techs and a lot of students get mixed up is using the prefix conversions. So they're going to go through in detail how to read the meter properly. And then we're going to use Ohm's law. Ohm's law relationship. That's what we're doing is to teach a person to use Ohm's law. And a lot of the students will tell you, I don't need to know that. Yeah, you do, because you're using it every day. A lot of techs out in the field also have the same thing. I don't need to know Ohm's law. Yes, you still have to be using it, and they're using it without thinking about it. Now, the trainer comes with a couple of accessories. There's 3 color wires. So we have red leads here, and the red leads are for your power circuit. We have a set of black leads here, and the black leads is you're using your ground. I have multiple grounds, 2 ground. And then if you're going to build circuits, there are 6 blue leads that are going to be using that. And there also is additional at the bottom of the trainer, and we'll show you again in a few seconds here, is the optional sub-mount units where you can put other accessories into the unit. Like say a relay, you can put in a solenoid, something else you want to look at. Big one is evap solenoids. Purge solenoids, you might want to look at those. We also have a student guide and an instructor guide that come with it. Now, if you're using a student guide and instructor guide, they're there. And this one's showing you the 4810 electrical trainer. There's a hard shell storage case in it. But here's the deal. If you're storing this board away, and you've got a lot of the students I've worked with over a period of time, you want to protect some of this device. Or if you're on one campus and you have to go to another campus to do some of the training, you store it one place and you have to move across. This is a good accessory that you might want to use. And it protects the boards, has all the information in there. Also, there's a 4810 and the 4820. You're going to see both boards up there. Has a little bit of the instruction guide on how to set it up and how to use it. The courseware is available in both English and Spanish. So a lot of times what I like doing is be able to use the Spanish side and go over to read the English side. So I have a little bit of way of learning to interpret things, and when they say something in their native language, I can kind of understand. The other thing about it is it also can teach some of the students what would be in English, because if you think about it, where's all the manuals that you're going to be working at? Most of the shop manuals we get are in English in the United States, so we have to have this. Other parts of the world it might be different. The other thing about it is we have an accessory or another additional board that comes up is called the 4820. It's called the Electromechanical Trainer. The reason being is it's going to have relay operations. You're going to have create magnetic fields. We're going to have electrical generator, which I use a lot of times to teach guys the regenerative brake, because you can have one motor pulling another motor, and it shows you that you have regenerative brake if you're looking at that. You're going to be able to test power, voltage drops, a lot of stuff you're doing, some diagnostic testing. Again, the 4810 construction, we're going to go start talking about that. On the 4810 Applied Electrical Trainer, we have basic operation components. You have to have a 12-volt power supply, which is at the top, and when you do that, you also have a little LED telling you the circuit's on. There's an on and off switch, like I said, with an LED indicator. If you go down, we also have a switch at the bottom that's going to be able to switch voltage to the circuit. We have a momentary switch at the very bottom, like if you were going to check for a horn or something that only comes on part of the time, that's there. We have a circuit breaker. We have to have some kind of breaker in the circuit or a fuse in the circuit, so we are going to use a circuit breaker in there for our protection device. That's on this side of the thing. And if you notice, we have at the top, we have 12 volts, we have ground, and we have a 5-volt signal. So I can put 5 volts out. So if you were testing a sensor, or you just want to use a 5-volt reference just to show how things change with a 5-volt reference, you have the 5-volt jack there. If I come up and look at a couple other things up there, there are 3 ground jacks on this one. Now, if you notice, I have a ground up here, I have 2 grounds here and here. Personally, if I'm using this meter, most of the time, I'm going to use my ground here. I find it difficult to use the ground up here. I like using my ground here at the very bottom, so that's there. If I'm looking at this circuit or this circuit, I can feed my ground over into here. So it makes it a little bit easier for me to use the tool. Now, if we're there, we've got that. So that's our main parts on this. I always call that this side of the screen. If I come over my next one, I have a middle row. And the middle row is going to have resistors. So if I start out, I have 3 120 ohm resistors. And the reason they use these even number resistors is for safety, as they limit the current and wattage across the board. We do know students will tend to experiment a little bit, so we're going to add a little protection for them as they go across. But it also allows you to do a lot of variety of circuits you can build. So I have 3 120 ohm resistors, 2 240 ohm resistors, 1 680 ohm resistor, and 1 kilo ohm resistor. That's in the center. So these resistors, again, are in there for safety and limit. The other thing about it is, by having even readings on this, it's going to allow me to do my math a lot easier. It's going to make it easier for them to calculate Ohm's law when they're using it. Now, if I'm going over and looking at my next side of here, I have 2 14-volt bulbs, 2 28-volt bulbs, which are here and here, and then at the bottom I have the auxiliary jacks. And I told you about the auxiliary jacks. Those are things we can add on, like the relays, or like a solenoid, or the big thing I like to do is check evap solenoid sometimes, show them how they work, because they're going to open to allow the flow and close not to allow flow on it. So there's a couple things there you can look at. Again, you have 3 different areas you can use, and again, this is the control, is on the left-hand side, the middle is the resistors, and you're looking at those, and then we have the loads on the right-hand side. I want to go out and start and use a basic circuit that we'd see on a car. Now, the basic I'm going to build is a series circuit, and it might be the dome light on the car. So if I was looking at it, first thing I need to do, I need 12 volts for this circuit. So I need to feed it in my what device? My safety device. So I'm going to feed this into my circuit breaker. And from my circuit breaker, I'm going to feed it into my switch, which if you were looking at the wiring diagram, you have to feed out where the switch is. Again, you can associate this with a different circuit and apply it through. So I have my feed. As I've got I'm building my feed in the circuit right now. So I want to feed from my switch over to my load. So I'm going to go from here to here. Now to complete the circuit, I have to have some kind of ground. And I've already talked about the ground, so here's the deal. We're just going to take black lead and we're going to put it to ground. All right, so that completes. That's a simple series circuit. And I realize that if I build this one of the things I want to remind your students to do is not wear jewelry while you're working around electricity. Did I make a mistake there? Yeah. So I'm going to take my watch and make sure it's off right now. So right now, my circuit is fed, but nothing's working. What I want to do something as a curiosity, I've been doing this with a lot of people I've been training lately. So I'm going to pick my voltage there and my ground. I'm going to turn my voltmeter on. And on my voltmeter on, if you'll notice, I got 12 volts. So I have 12 volts. This would be the open circuit voltage at the battery being fed into the circuit. Now, if you read 12 volts throughout the circuit, that circuit's open, because the voltage should drop as you use some electricity. So if I turn this on, notice I went to 11.97 volts, and notice my light's on. So I'm actually feeding voltage into the circuit. Now, if we were talking about this and I was checking a circuit, there's different ways of checking it. Some people start from the fuse and work their way down. Other people start from the ground and work their way up. Doesn't make a difference how you do it, just as long as you do it. So I'm just going to go up here. I have 11.97 there. 11.97 into my circuit device, or my fuse. That's why we should always check a fuse on a circuit to make sure it's correct. And then I'll go on my other side of the fuse. I got 11.85. So I know for a fact on that circuit breaker I have dropped some voltage, which you will drop voltage as you go across. It's being used up as it go across on here. So out of curiosity, I might want to do a voltage drop right off the bat. So again, I take my red lead and put it on the most positive side of the circuit, and I take my black lead and put it on the negative side of the circuit. Some of your instruction manuals on the factory tools that I've been looking at later will call it B plus and B minus. Same thing. So I'm going to do this immediately. And look at what I've got. I've got 0.12 volts. That's okay, it's 0.12 volts. Well, I also can take my meter and flip it over to millivolts, and it says what? It's a different reading, but it's the same. That makes sense. Here's the deal. Again, this is something you're going to learn to use on your meters. It says 0.12, so I really want to know what the millivolts is, and it's 117.2. And if you look at that right there, it says millivolts. On this side, it says volts. So sometimes it's a good idea to adjust your meter. I also could come up over here and hit range. And right now it says 0.117 volts. Sometimes when you're using your tool, all these auto range tools, sometimes you still have to hit the range button. You need to address that with your students to make it a little easier to use. So I have dropped, and we'll go back to the range I was before. I have dropped 0.12. So I know I've dropped a little voltage across that. So when I come over to put to this circuit, put my ground up there, notice if I got it right, I got 11.84. So I have dropped 0.12. And if I'm coming back over here and looking at it, I should have, if everything's good, okay, 11.85 over in there. So we have a little bit of a difference, but it's still there. And then after that, if I'm looking at my circuit, notice I have 0. What it tells me right now is I have a good series circuit. It means that I have had a little bit of voltage drop coming over there, but at this point, if my device and my load's here, it should use all the voltage. If the load doesn't use all the voltage, we have an issue, or I have a bad ground. When I got a good ground here, if I wasn't doing the work, that would indicate a bad load device. So that's one thing we can look at. The next thing, if you're looking at this particular circuit, I can play around with this a little bit. Let's have some fun with this one. Let's go back over and do our series circuit. All right. Now I've got the 28 volt in the line, and I'm just going, I should have really turned it off. All right, so I'm going to turn this back off, turn this one back off again. Now, out of curiosity, I'm going to start my feed voltage. I'm turning it back on. Notice the light's on, it's dim. I still have 12 volts, right? I got 12 volts there. I'm still doing the same process, doesn't make a difference up there. And notice that this one, I got 11.97. So that immediately knows that I have more resistance in the circuit in the process. So what I'm going to do right now is voltage drop this device and have some fun with it. 0.02, all right? So notice it's different. Not all circuits are going to be the same. That's why we must tell our students that they have to test the circuit. If they don't test the circuit, they're going to miss something. They're going to assume something's there, and it's not there. So again, back to ground, and I can follow this down. I'm going to go to my load. There we go, 11.97. And on, if I'm looking at 11.97, I'm going to take it and go over after my load, 0 volts. So that tells me we're going through. So another way to check a load in a circuit is do a voltage drop across it. So one of my favorite things to do is always go into my circuits, do before and after my load. Notice what it says. I dropped 11.97 volts. That means that circuit is working properly. That is there. Now, if this was a dim bulb, what would that indicate to you? It might be the wrong bulb. A do-it-yourselfer sometimes don't always put what they should back into a circuit. It looks the same, so they put it in. So it tells me, if I'm looking at, I should use all the voltage coming up the circuit, so 11.97. If I go to here, there's my 12 volts, all right? So I have 12 volts. Total drop in the circuit is 12 volts. Well, I only dropped 11.97 across the load. Where do the other voltage come from? The other connections that we go through. So that's showing you how to easily test a circuit. The whole idea of this is to teach a student what they need to know. Let's just have a little fun here. I'm going to go over here and add in another device up here. So I'm going to take this one up here, put this one here, this one here. Now, I got 2 loads in a series circuit. But if you notice something interesting, I only have 1 bulb lit. Okay, normally what happens is the highest resistance in the circuit will normally pull more voltage in a system. So if you're looking at it in process, it sounds a little weird, but let's do this. So if I'm looking at the problem again, let's go back to where we started. Well, I have to put my black lead back in. Guys, you never mess up like that in front of anybody, do you? All right. Okay, 11, I got 12 volts going to the circuit, right? Okay. Notice that was a little different. And again, I'm going to go before this one, put myself down again. There's 12 volts before it, and notice I have 0.03 of volt. All right, same process. Now, if I go before my load, I'll get this in, 11.97, okay, which I should have. If everything's good, I should have it. I know I had, what, 0.03 here? If I go after this one, doesn't look like I'm using much voltage at all on that point. If I go back over here to the next one, 11.32. So, and honestly, got a little bad connection right now. 11.32 right there after it, and I had before it 11.97. So I can actually voltage drop each individual component to see if it's working properly. So what I'm going to do right now, take my black lead here, see if I can make good contact. And, you know, voltmeter leads will always get twisted no matter what happens. I don't care what you do, you're always going to have a twisted lead somewhere down the line. So I'm going to put my black lead afterwards, which is my, what, on the most negative side of it. And what did I have for voltage drop? 0.65 volts. Well, if that was only one load, I should have used all the voltage. Did I? The answer is no. So I know there is an additional load in the circuit. That could be, if you look at it, that could be voltage on the ground, being used. So I'm going to go over here. Red's going to go in to that one. And I use 11.32. But if you notice something, my circuit's here. That would be like an additional load in the circuit. In other words, this would be resistance that we came up and show it. So I have a voltage drop of 11.32 and I had 6 over there. So again, if I take my red lead and my black lead and move them across, there's no voltage on the ground. So I used up all the energy. If I was doing this and I came up here, I only dropped that across here, that means there's another load in the circuit, another resistance in the circuit in that process. So my other resistance would be here. Some of you instructors old enough to probably remember the Quad 4 on General Motors. And they had a deal where I actually had some bulletins out, if you go back and check this, where they would tell you when you're checking the injectors on the Quad 4, what would happen was one injector would pull all the energy, just like this just did here. The problem about it is one injector would shut down, just like the light just did here. The problem was that the one was using all the energy in the circuit, just like this. So in other words, you have to understand you should do voltage drop on both components. And you have to look at the series, the circuit as it goes across, and an issue on whatever the problem is. Biggest thing about it is this is where you would be able to do testing on it and getting that across. Voltage drop will be their friend. If I would ohm these out, there's an issue up here. If I ohm these out, what happens? If you have a bulb when it's turned off, notice if I have a bulb up here, let's just get this out and look at something a little differently. I'll take the black lead, switch it for this one. I'm just going to go one in here. Notice this one's out of the circuit. There's my simple series circuit. I drop all the voltage across here. But the same thing is I'm doing what? I'm doing work. So I'm providing light. The other thing is over a period of time, the biggest problem you have with teaching anybody is when you ohm out a light bulb and it ohms out one way and they try to calculate the amperage load in the circuit at that point, it's not going to be the same. So here's the whole deal. You have to have the circuit live and working. That's why this is designed this way. I can ohm out things all over the day, but if I'm working, if I put my finger up here, it's starting to warm up just a little bit, not much, but I have the light. I'm doing work, so it's going to do what? Transform the electrical into work. Light, movement, heat. That's why when we have a short to ground, what happens? It actually heats up drastically because we have work. We're going to ground. We're not going to do any work, but we do have a short. This is showing you all the load and vice. Everything should jump right here. This is converting it to heat, like we said. Now, the next thing we can do, having a little fun with this, I'm going to put my black lead here. I'm going to take this one. And notice I have one bulb lit right now because I haven't provided a ground to this one. So I'm going to do a parallel circuit. Now watch. There's a parallel circuit. So in other words, we have two circuits up here. We're going two different paths. We can have a voltage across each path should be the same, all right? But what I wanted to show you is a lot of people have a little problem with this. So if I'm coming up here and I have a parallel circuit, I'm feeding voltage from where? Right here to both circuits. I'm applying ground and doubling here. This could be backup lights on a car. That's a real good choice with backup lights on there. It might be tail lights on a system where they come on. It's a parallel circuit. Now, if again, I'm going to flip this back on, and I'm going to look at voltage into the circuit if I can get it. Don't like me right now. I have to hold it in there a little bit. 11.69 volts, all right? And if I'm looking at a circuit going across, and if I push it over here, I should drop all the voltage in the circuit. Notice I drop all the voltage at 0.01, no problem. If I go to this other circuit, 0.01. I can also do a voltage drop across a parallel circuit. We'll do that one again. I don't have to do it that way. I can do it this way too. Across my load, and 11.68. So there's some resistance somewhere else. The neat thing I will look at on a parallel circuit, if I remove voltage to one side, so I'm going to remove what on this one? Ground. The only circuit is what? Having a problem would be the other circuit is okay, so the problem it has on the circuit it is. So if I'm feeding voltage to both circuits on a parallel circuit, the light bulb can go out. If I have a bad bulb on a series circuit, that means the whole circuit goes out, so it's a little bit different. If I come back over here, that is on the ground. Let's say I lose power to this side. The other side still works. So we have ability to look at the parallel circuits going across, all right? Now, out of curiosity up here, there's one issue that we're going to run into. Let's try something different. All right, we'll do it the right way. Turn my power back on, and I'll turn my switch back on. Now, at the same point, I got two bulbs in there, but they are different resistance. So apparently, if we look at this one's dim, but I'm still going to use all the voltage going across that circuit. So let's look at the process. I can have two dissimilar readings on it, and they will learn the math and the procedures. The other thing is, you have to keep this in mind, it's a lot of fun playing with students. And one of the things I like doing with them is doing this one. Is if you're looking at a student and having some problems with it, you want them to calculate the resistance in the circuit, key on, off, resistance, because there should be no voltage in the circuit. Then you want them fire and calculate at the 14 volts, whatever feed, calculate the amperage. Well, there's a problem with that, because when that bulb lights up, it changes resistance. So that's the only exception I found to Ohm's law. And you have to teach that to your students. Now, if we were looking at this one, if I wanted to make sure that the light bulb did not affect me, I would automatically take my same circuit. Notice it's still working. And I'll turn it off again. All right. Turn it back on. Now I don't have any visual cues. I don't have any cues telling me what's going on with the circuit. So that means I'm going to have to use the thing between my ears, and I'm going to have to use my voltmeter. Again, we hit source voltage, notice 11.98. It changes all the time, if you notice, by the resistance. So there is no way all the circuits are going to be exactly the same. If I put into the circuit, I dropped what? Just a little bit of voltage across the resistances that go through. There is a voltage drop. If I go to the other side of my circuit, it says 0. That means I have lost the voltage because I have used it up across this resistor. You have to be able to teach them to use resistance and not always make sure you have to have a light bulb to do the testing. If I'm doing resistance, I'm going to turn the circuit off. No power. If we're doing resistance, the circuit should be what? Off, not working. Because I don't want any voltage running across it. Your voltmeter will put out a slight bit of voltage, like 0.6 volts when it's doing an ohm test. A little higher when you're doing a diode test. So if I'm looking at this, I want to see the ohms across here. What I'm going to do is just do my old nice little thing up here. I'm going to go across. All right. All right, so I've got 59.6. How can I have 59.6 on a 120 ohm resistor? That's because the circuit's in parallel. If the circuit's in parallel, that means I'm going to divide it in half, basically. When you start teaching CAN networks on cars, you always notice if you go across the circuit and shut it down, if you go across 6 to 14 on the circuit, there should be two 120 ohm resistors in the circuit. If there's two 120 ohm resistors in the circuit, then this will drop down to 60 ohms. Now, if you're using your ohm meter, You must teach, as emphasize this a lot, you must teach that you have to disconnect part of the circuit. So I'm just going to take this one out and watch what happens. Take my red lead, and I'm taking my red lead on it, and I'm going to find my black lead again, which is over there. And if I have my red lead to right here, I have 118 ohms. Well, I have 120 as a revolution. There's a little minor variation in resistors, 2% difference. So that's a proper way to test it. So again, if I'm in a circuit and I'm checking resistance, I need to remove one lead. And that's why there's an emphasis on the testing. When you go through the testing procedure in the manual, it actually tells you that you need to disconnect each component as they go through. If I wanted to measure resistance of this circuit breaker, what I would have to do is disconnect, take my red lead off there. Notice I got my red lead loose. I would actually have to go from here. Let's see if I get a reading on it. Sometimes you don't get a good connection. And to here. So right now I know I have 0.9 ohms resistance across the circuit breaker, which is okay. I could check my switch. If there is established voltage or established resistance reading, that's a great idea. If you have no established reading for resistance, you need to teach to use the voltage drop method. If I'm looking at all this, the last thing I wanted to do, I'm just going to do the current. I'm going to build the circuit one more time. You have fun playing with things up here occasionally. So there's my 12 volts from my circuit breaker. All right, and so I've got this coming out, all right? I've got blue. So if I'm doing this one, always keep in mind, when you use your voltmeter and you're using voltage, the voltage crosses from here going to the ground you provide. If you're doing other things, when you use amperage, you must be in series. So if we're looking at this particular circuit, right now nothing's going on, I'll pull this lead off, turn the circuit on, and you notice the light is on, all right? But to do amperage, you must break into the circuit. That's why a lot of techs have gone and students have been learning to use low amp probes because it makes it a little bit easier. But if I'm using the amperage on it, notice the voltage drops as it went across. So I'm going to turn this thing off, and I'm going to check my voltmeter from here, and I'm taking my black lead and go here. Turn my circuit on. If I get good contact, which I didn't, there we go. If you notice, I got 246 what? 246 milliamps at M, milliamps. So if I was using this, I could actually change my range. Notice it says 250.25 amps. Again, you have to use your circuit the best you can. Sometimes it's a good idea. I got 246 milliamps. All right, that's on the feed side. So where would I go next? Where would I go next on this circuit? And the next on this circuit would probably, I want to go to what? We'll turn it back off again. So we have the circuit there, and I've lost my red lead for a second. We'll just use a different one. No, it isn't. It's right here. All right. So I got my circuit breaker up here. So where else could I check? I could check on any part of the circuit. I would have the same amperage. I should have. So I'm going to go to the ground side. And I'm going to hook, you always have to do polarity for some reason. There's my ground. And turn this on. And if you notice, I have what? 245, 246. I'm pretty close to the same, a little difference. It has to warm up to make its job. So again, I can check current on either side. Series circuit is real easy. You would actually break into the parallel circuit, and they will instruct you in the manual how you should do that. As you can see, there's 30 separate activities included in the courseware. I only went over a few of them, and I just ad-libbed on a few of them, like you're going to do when you get the tool. The whole idea is to be able to teach the student to go over and diagnose circuits. And with this tool, you can actually set them aside, let them be able to do it on their own, because you're going to have some of the students that will work through this software really quickly on their own. There'll be other students that we're going to need a little help as they go through. So you're going to be able to modify things to make it sure that they understand the principles of electricity and electrical circuits. If you need additional information on further training on this device, the 4810, or you're interested in purchasing, please contact ATech. If you enjoyed this ATech instructional video, don't forget to share, like, and subscribe. My name is Jim Wilson. I'll see you next time.